Jim, what do you think about shooting stars?
Probably UFOs. I mean, if we're being honest, right?
Have you wondered what they are? Do you know what they are? Or do you think you know what they are?
Let's see. I mean, I feel like I've heard that some of them may be actual like little comets, I guess, right? And then I've heard also that plenty of them are maybe satellites.
Okay.
Nowadays that we have so many out there, but that's about it.
Oh my gosh, that's very exciting. Okay, well, let's get into the chemistry behind shooting stars.
Okay, sounds good. Let's do it.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
And if you're new here, if you haven't been around for a while, my name's Melissa. I am a chemist. I have a PhD and a master's in biology and a bachelor's degree, all in chemistry.
Mm-hmm.
And my PhD specifically focused in education, but I do have lots of organic chemistry training in that area as well. So, and I just love talking about chemistry.
Mm-hmm.
And I just love trying to make it accessible. So that's what I'm trying to do.
Yep. And so that's why Melissa says she's a chemist every episode, to make sure you know that she doesn't know everything about chemistry.
Nope.
But she knows more than most people do.
Yeah.
And knows how to dig into a topic and research it and figure out what's happening.
Yeah, that's what being an expert is, I think. It's not knowing everything. It's knowing enough to figure out what you don't know.
Yeah.
So.
And before we get to the actual chemistry part, you may notice that we are matching.
We are.
This was not on purpose. We did not coordinate this, but it is a good chance to remind you about our Chemistry for Your Life merchandise that is available on our website at chemforyourlife.com/store.
Yep.
And this is was quickly one of our favorite things.
Oh yeah, I wear this all the time.
Collegiate sweatshirt. Mine's looking a little rough actually because of the number of times I've spilled stuff on it, spilled my own coffee or my kids' dinner on it, and washed it. But they are great, and it's a really good way to support the show.
Yep.
So just go check that out if you haven't already.
I wear mine to work because I work in a chemistry department, but also it's raining today in Denton where we live.
Mm-hmm.
And so it felt like a cozy sweater day. And so I reached for one of my favorite cozy sweaters. And this is definitely on the top of the list.
Oh, yeah.
All right. Well, now let's get into shooting stars. I'm really excited by your answer because I was worried that you'd be like, oh, I know this and this. I tested on Mason and he knew more than I thought.
Uh-huh. I just thought of one other theory that I remember people talking about, that it's like maybe little bits of stuff entering our atmosphere and burning up.
Okay.
But that's just the stuff you kind of incidentally hear. I haven't looked into it.
Yeah.
You know?
Well, I have looked into it. I looked into it a lot.
If only there's some way we could know, but I guess we just, there's just no way.
Guess not. All right. That's the episode.
Yeah.
Well, when you say the thing about a lot of them are satellites, it is really fun. Something that inspired this episode is we're kind of in this series of summer, and we went camping a lot this summer because once you have the stuff to go camp, it's like almost free to go camping.
Right.
And we were in Rocky Mountain National Park at the new moon, and it was so dark there, and you could see the sky so well. We even saw that we could see the Milky Way. I took a picture of that.
Nice.
And we would do yoga at night and then just lay there and look up at the stars. And you can tell the difference between satellites and shooting stars. And I think there's like a Coldplay song or something where they talk about shooting stars or satellites.
Huh.
And I always think of that song. And
wait, how's it go? Could you sing it real quick?
Yeah, I'll do it. Just off mic. And while we were there was one, we were watching, just looking up at the sky, and there was one shooting star that came and its tail was really long and it lasted for a really long time. And I was like, that was crazy. And I was like, what was that? Like, what was it? Really, what was it? And that inspired this episode. And I feel like this is a nice way to sort of wrap up summer.
Yeah.
So our final days of summer, we're getting into fall. It was cool weather today. This week we had some cool weather. So I thought this would be a nice thing to sort of cap that off.
Nice. And yes, we know that summer vacation is over, but it is still, at least we are for a while longer, the weather is exactly the same. So it's like, it is summer until, well, I guess here until October, but yeah, whatever.
Sometimes it's like, I remember growing up, it was really a 50-50 shot. Is it going to be hot on Halloween, or is my costume, am I going to be able to wear it, or do I need a jacket over it?
Yeah, that's good.
Or is my costume going to be too hot? You know, it's like those are always the questions on Halloween growing up.
Yeah.
Okay, so before we start talking about the actual shooting stars, I do want to do a little chemistry lesson here at the top of the show.
Okay.
And it's about gases. We've talked about gases a lot, so I want you to picture gas molecules in your mind. They're, individual molecules floating around and moving around, and there's just a lot of empty space between them. So like this air is a lot of empty space, but there is a solid concentration of molecules in it, but they're just not very close together.
Right.
Okay, and outer space has even less, like not very many at all. It's like lots and lots and lots and lots of nothing out there.
Yes, it's yes.
Okay, but our atmosphere has molecules in it. And the thing about gases is if you try to force them close together, you increase the pressure on them, the temperature will also go up.
Okay.
Because you're pushing them close together, and molecules are surrounded by electrons, and those are negatively charged, and they're repelling each other. So they're trying not to interact with each other. And if you put that increased pressure on them and you make them be in a smaller volume, they're going to move around more to sort of counteract that.
Right. Okay.
Okay. So you will, if you increase the pressure, you can increase the temperature of gas molecules. Okay. So what happens when we see shooting stars? It looks so beautiful and peaceful from down here. But up in the air, you have shooting stars are pieces of rock or metal in space. Most of them are pieces of rock or metal that came from the Big Bang.
Okay.
So like, initially, our universe started, everything was in this is what people believe, in this one small point, and then scientists believe.
Yeah.
And then there's like essentially a burst of outward energy, and everything started to expand, and it's still expanding. And that is what started it all. So there's lots of rocks and metal floating in space.
Right.
And a lot of those are thought to be from like saving the chemistry from the very beginning of time. Okay. So that's kind of good information.
And I will say too that this is intersecting with like an area I like to nerd out about, which is just I'm obsessed with outer space ever since I was a kid.
Oh, I didn't know that.
Even though I hadn't looked into shooting stars specifically and don't know the answer about that, there's so much about space that I just will go watch YouTube videos about and read articles about for no reason whatsoever. So
that's fun.
I'm loving this.
Oh, that's
already.
So exciting. I was a little worried it might be too boring.
I mean, I do think that shooting stars are not the coolest thing in the world until maybe I learn about them more. But I kind of forgot that there's going to be a space part to it. There's so many things that people talk about in terms of like gazing at, and what for one, I think I'm a little annoyed. I'm like, I know they're not stars, okay? So it's like when people say that, I'm like, it's probably not a star, but I never went and looked into it. But I am realizing how my curiosity could have led me to a place of like much more intrigue, and that is what's happening here.
So you were mad because people are like, I'm looking at these shooting stars, and you're like, they're not shooting stars. No.
Yeah, I can't, and also I can't really put my finger on it, but there's things that I like. People freak out about rainbows, and I'm like, they're not that cool, everyone.
Hey, okay, the chemistry of them is cool.
Yes, but there's something about this, the contrarian in me, that feels like there's things that I've heard over and over like for our whole lives, you know? You're like, ooh, it's a shooting star. Or, ooh, there's a rainbow. I'm just sort of like, I've seen it, okay?
Wow.
I've seen it.
So what he's saying is they're saying that other people love to love that he loves to just be a grump about.
Or
Scrooge.
And I can't put my finger on why certain things are like that and other things I'm like gonna continually be interested in and obsessed with. You know what I mean?
I will say a cool thing about rainbows is the reason that they have that shape is because of hydrogen bonding, which is an intermolecular force. And that's cool. That I can tell you why rainbows have arcs because of science.
When we did a rainbow one, I don't think I went into it very much, but I think I did say something to the effect of like, I didn't really think they were that cool until we talked more about them.
That's true. Yeah.
But, yeah, I don't know. There's something about, and then also I think the other thing that annoyed me in early social media era, people would take pictures of rainbows and the pictures never look good. Like, especially if it's like the iPhone 3G or whatever from back then.
Yeah.
In like the early Facebook days. And I just would kind of this feeling of like, just keep it to yourself and then just like enjoy it. You know, like now we're looking at this like, I can kind of see it, you know.
Oh, gosh.
Pixelated.
Okay, well, hopefully you like shooting stars by the end of this. And you're right, they're not stars.
Nice.
So.
Nice.
Okay. So imagine you're in outer space and there's this metal or rock, flying through the air, minding its own business.
Yes.
It's going, I think the number, so I forgot to write down the units, which is like a cardinal sin, but it was 40,000 to 260,000 kilometers per, and I don't know if it was second or minute or hour.
Wow.
But either way, like even, 260,000 kilometers per anything is crazy. Okay, so it's going really fast. I can't believe I forgot to write down the units, but it's going really, really fast. Traveling through nothing. And then it hits our atmosphere, which has lots of molecules already there compared to where it has been.
Right. Oh, yeah. Right.
And so that impact, when this rock or metal hits the atmosphere, compacts these gas molecules so rapidly that it causes a super increase in temperature.
Okay.
And so it heats up really, really fast. And it can get up to 2,000 degrees Celsius.
Wow.
Which is crazy. And so as we're entering this air, our rock comes from outer space, hits this air, things start heating up. They're heating up so much that a phenomenon called incandescence occurs. And we've all seen incandescence because that's what makes like traditional light bulbs, is you heat up the metal so hot, it has so much thermal energy that it starts to let that out as visual light.
Okay, yes.
So we're heating up this ball of rock and metal so hot that it begins to glow, essentially.
Wow.
And not only does it begin to glow, but it also begins to first liquidize and then turn into vapor. It essentially boils.
Wow.
So the solid rock gets so much energy that the molecules start to move around, which is really hard to do for rock and metal. They start to melt and then they become the gaseous form of their molecules. And as that's happening, it's becoming this like liquid and then gas. The whole fireball is still moving. The whole, I guess maybe fireball is a bad name for it, but this whole glowing hot rock is still moving at such a rapid speed that all of that liquid that's vaporizing is being blown off. So that top layer is being removed. Scientific word for that is called ablation. And it's just being left behind in this glowing streak of hot material that's turned into gas.
Wow. Dude, that's way crazier.
Isn't that crazy?
Yeah.
And there's so many fun, interesting facts. That's sort of the chemistry of like, what are we seeing? But there's more to it. That's not all that we're seeing. There's more. That's, we've got this nice streak of light and that's sort of the basics. There's so many fun facts, but I felt like that was a good base chemistry lesson of like, okay, we're compressing these air molecules, these gas molecules. As they get closer together, they're going to not want to be close together. The energy will therefore increase and they will start to heat up. And then that happens at such a crazy pace that it gets so hot that we're literally just making molten rock / metal in midair. Isn't that amazing?
Yeah, that is amazing.
So that's a little bit. I have more of the science behind shooting stars.
Okay.
And I should say probably somewhere here, meteor, I believe these definitions are meteor is what we see. If you like see a shooting star, you're seeing a meteor. That's what we call it.
Mm-hmm.
Meteoroid is the rock itself.
Okay.
Or rock and metal is usually mixed together.
Uh-huh.
And then if it hits Earth, we call it a meteorite.
Yes. Okay. I don't know if I had heard of meteoroid, which makes sense. Like, I guess it's like a brief state between or whatever. But it's like meteorite and meteor. I think I had at some point been explained the difference there. But,
and there's also, you mentioned comets at the beginning. Comets are very similar, but they like got blasted in the beginning out to the cold parts of the outer space. So they have ice on them. So actually, if they enter our atmosphere, they have two trails behind them. And one is like a water trail, and the other is it's like ions or molten rock and metal.
Okay.
And so they'll have two tails coming behind them.
I think I've seen pictures of that, but I don't think I've ever seen that. But man, that's crazy.
I know.
This is reminding me that my grandfather had a meteorite on like this little stand thing on his desk. And I have got to find out a story about that.
Okay.
From my mom or whatever. But like, it was not that big. And I remember hearing that like, yeah, I mean, most of them, if they're sizable enough to actually make it all the way to the Earth, when they do, they'll be smaller and stuff. So but it had this just very odd look to it.
Yes. Did it look so? Something that some of the resources I saw said is like when they get to Earth, they don't just look like rock. Because the outside is like melted and then it's cooled back down. So the outside looks different than regular rock.
Yeah, it did look melty. It looked kind of like just smoother than you'd expect.
That's so cool.
I'm like, I wonder where that thing is. I've got to find out. I'm sure one of my uncles has it, but you know, that would be so cool to figure out. I'm sure I know one of them would know the story. Yeah. But I gotta download that story while I can. You know?
You got to. Okay, well, do you want to try to say that chemistry back to me? I feel like it's pretty like basic lesson, similar to what we've done before. And then I'm going to give you just like facts after facts after facts.
Deal. I'm very down for that. So these meteors are bits of rock and metals combined that have been flying around like crazy since the beginning of the universe.
Yep.
Just waiting to hit something, basically. It's like somehow they haven't hit anything yet.
Yeah.
And they're just going around. Probably their path gets a little altered by the gravity of stuff or whatever.
Yeah, it did say that a lot of times they'll fall out of orbit if they're like, they get messed up by the gravitational pull of other things.
And when one heads toward Earth, well, first, before that, what it's flying through all the time is essentially a vacuum. It's like there's obviously other things out in space, but there's not close together air molecules that are like they are in our world here.
Right.
So it's flying through a one type of medium that is much sparser. And then when it hits our atmosphere, there's way more gas, way more close together. And so as soon as it does that, it starts like pushing on those gas molecules and like increasing the pressure on them together, which turns them at first into liquid.
Not the gas.
Not the gas. That's the meteor itself.
Yeah.
Okay.
So it pushes on. I'm so glad we did this. The meteor pushes, or the meteoroid, I guess,
Meteoroid.
pushes on the gas molecules, and that heats the gas molecules up.
Okay, heats it up.
But they're already gas.
Right. Okay.
So they can't get any more gassy.
Right.
You know?
And it wouldn't be pressure in a way of like condensing it, right?
I think it does sort of, it doesn't turn it into liquid. Yeah. But I think it's the pressure would be really high, but the temperature is also really high. So it would be hard to be the liquid state.
Right.
That's a really good question.
Right. So that happens, gets super hot.
Mm-hmm.
So not exactly fire, but something that definitely affects the visibility of it.
Yes.
And at the same time, the meteoroid, right?
Mm-hmm.
At this point, is itself being changed by this experience.
Yes. So the thing that the air gets really hot, the gas molecules get really hot, they're not the ones that are glowing.
Okay, right.
The light and the glowing come from the meteoroid getting hot. And
so the incandescence stuff is the meteoroid.
Mm-hmm.
It getting hot and having the effect of light bulb, just like the filament or whatever, starts glowing because of its something.
Yep. It's incandescence happens when there's so much thermal energy that it gives some of it off as light. So you've seen this before, even though it feels like a weird phenomenon. Like if you've ever seen metal smithing, it's like scenes in movies or like cattle branding, they get the metal so hot that it starts to glow. Yeah. It's just like that, but crazy intense up in the sky version of that.
Okay, yeah. So it's literally just the heat that we're like, no, it's not crazier than that. That's interesting. Because it is like, like you leave the fire poker in the fire and it gets glowing. I remember doing it as a kid, being like, thinking about, metalsmithing in movies and being like, whoa,
yeah,
we just did that.
Yeah.
But not really thinking that that's the same thing that's happening in light bulbs and meteors. Wow.
But there's more than that with meteors, because it gets super hot enough to glow. And then it essentially brings it from a solid to a liquid to a gas. It essentially boils that rock.
That's where the state change is happening, not on the gas, but on
the rock.
On the rock itself. Okay. And so if it's depending on its size too, that could fully happen where the whole thing turns from solid to liquid to gas.
And it's gone.
Then it's gone. It's kind of this streak is left as it
Mm-hmm.
vaporizes or whatever.
Mm-hmm. And the streak is literally just like a streak of metal vapor that's really, really hot.
Wow.
Metal and rock vapor that's really hot. There's some other theories about long-lasting trains, is what they're called. But that's essentially what it is. It's like you're seeing the trail of layers of the like meteoroid rock that have blown off as it's rushing through.
Wow. Dang.
I try to think of like, it's almost like power washing, or the thing is called ablation, and like there's other like ways of doing that. There's like other fields that use that technique, but I'm like, it's just blasting a layer off layer. You're like turning it from solid to liquid, and then gas is getting blown off, and so you're just taking maybe like a gobstopper, but each layer is leaving a trail behind on your tongue, right? It leaves a color trail behind on your tongue. So, so that's, I think you did a pretty good job. Do you have any questions?
No. I mean, you cleared up my confusions.
Okay. Great.
And my the wires getting crossed that quickly, trying to repeat it back. But yeah, man, that's crazy.
And that heating up in the rock becoming a liquid and then a gas, that's why the outside of meteorites are liquidy looking, is because they essentially melted. But they just never got the chance to evaporate because they hit ground and stopped.
Got it. Okay.
Okay, are you ready for a variety of fun facts? Okay. There are layers of metals and metal ions way up high in our atmosphere.
Okay.
those are left behind by meteors.
Okay.
And they can interfere with radio transmissions. Isn't that crazy?
Wow.
I just thought, I don't know why I thought this, but I was like, okay, yeah, so our atmosphere is like just the traditional gas molecules that I know about.
Mm-hmm.
But no, there's like a sodium layer and things like that. And I don't think they're permanent. It seems like they're changing kind of.
Uh-huh.
But the meteors can leave behind layers of metal. And there's lots of meteors hit,
Wow.
quote unquote hit, come into our atmosphere, I guess.
Mm-hmm.
One thing said you can typically see between like 6 every hour in it from a dark sky area.
Wow.
So, and when I've been out camping, I've seen anytime it's been dark.
Uh-huh.
2 times I went camping, it was pretty dark, and I did see multiple shooting stars both times.
What's crazy is that bit of like space debris or whatever would, if it's happening that frequently, that would definitely damage satellites. Like if it was hitting them, which I'm sure that's still like hard to like hit a bullseye like that from forever away. But it's like still
because like Earth is kind of big compared to those.
Yeah, but it does seem like the more satellites we have, the more chances there could be that like, I mean, if there's just space is just like lobbing meteors at us like
I know
all the time, it's gonna happen.
I know.
But yeah. Interesting.
So that's one.
Mm-hmm.
Another fun fact is that sometimes there's those long trains. They can last for several seconds or even a minute afterwards. And it's generally believed that the light from those trains is it may not just be glowing debris from the rock itself, but those metals then might facilitate reactions that involve oxygen, either like oxygen atoms or like ozone. They might catalyze essentially reactions with that metal and oxygen to have new chemical reactions that let light off. And as we know from our very famous and coming up soon green fire pumpkin incident, sometimes if you have metal ions in flames, they can make them colorful.
Right.
And that is what Mason and I saw. A colorful meteor came across.
Cool.
It was very bright and very colorful. And I was like, oh, now I know. There's probably metal ions in that. It was like green and orangey. Yeah, it was very cool.
Wow.
It was very cool. And he and I saw it, and none of the other people with us saw it. So sometimes they can be colorful because of the metals that they're leaving behind, making combustion reactions actually happen and then impacting the color. If you want to know more about that, you can listen to our episode about green fire. And here's another crazy thing. So human life is really, the building blocks of human life are proteins, and the building blocks of proteins are amino acids. We've talked about that before. And they're just these like repeating units of basically organic molecules to make these big long chains of proteins. Proteins are really long chains of repeating units, and the repeating units are like these smaller molecules. We like to call them smolecules. I use that in class all the time.
Around here, we like to call them molecules.
And so there's amino acids are the molecules that make up proteins that make up life.
Okay.
And, you know, the thought is kind of like, all right, well, we had this big explosion and we had some atoms and they were all on the earth. And then slowly over time, there was reactions that made amino acids on Earth, and that was sort of the beginning of life. And this, like, I've heard it called primordial soup.
Yeah.
Well, some of the meteorites that hit Earth bring with them amino acids.
Weird.
In the meteorites.
That is crazy.
Which seems like, okay, maybe amino acids were generated in the Big Bang. It wasn't just these individual atoms. But also, we've talked before about how molecules can be left or right-handed. And a lot of molecules on Earth have one-handedness. We'll just say one of the resources I watched, it was a really cool video, was the American Chemical Society.
Mm-hmm.
They were like, they just decided left-handed, so we'll go with that.
Yeah.
And those resources are in our show notes. It was a really cool little video. But the amino acids that a lot of us have in our bodies that are like most common in nature are that one left-handed, we'll say.
Mm-hmm.
And it's kind of odd that they're left-handed because you could have, in theory, they would be equally likely to form either way.
Yeah.
But the amino acids that are coming in from these meteorites are also left-handed. And so there is a possibility that if amino acids were initially formed in the Big Bang, there could have been like an energy source or something that was more likely to interact with the right hand than the left hand. And it broke down all of the right-handed molecules, leaving only the left-handed molecules behind, and explaining why on Earth, in our lives and our bodies, we're more likely to have the left-handed one. Could be from the beginning of time.
Wow.
In outer space.
Yeah. That's crazy.
So it can, like, what they're bringing from outer space can tell us not just about like what's out there, but also like, how did we start?
Yeah.
Which is crazy.
Yeah. And just that there's like, I think there's something that's so crazy too about this little artifact flew from some other corner of the universe, ended up here, and yet there's a similarity to it. We're recognizing what's here, and it's not crazy different, right? It's like, oh, this looks like this. This has the same amino acids as the left-handed ones. It's like the makeup. I mean, it could also seem to me as just like a not astrophysicist or whatever to be like, oh, the stuff that lands is super different. It's like from some other area, and that'd be like interesting in a different way. You know? But to be like, oh yeah, this never been here before.
Yeah.
But it's made up of stuff we recognize, including like things that are part of human beings.
Yeah.
Like that's so crazy.
So crazy.
But also then like makes our universe make more sense in some ways.
Yeah.
You know?
It like tells us about our universe.
Yeah. It's not quite as like, I don't know, is disconnected in that way. Like we're all just one big happy universe if you think about it.
Yeah. I've been enjoying thinking about the universe. I'm listening to a book series called Red Rising. Do you know about that series?
I don't know if I do. It sounds familiar, but nothing else is coming to mind.
It's really popular, but they've taken over the universe. Like they started on Earth, they went to our moon, and then they went out into Mars, and they're trying to like terraform everything to make it livable. And it's so then when I'm like learning about outer space here, it like feels a little bit more accessible because in this like sci-fi book, that's the way it's going. I don't know. Okay. Back to my fun facts.
Yes.
Oh, and one thing I read was, I don't remember which meteorite they were studying, but there was a team that like, okay, they were looking at the chemical breakdown of this meteorite, and they found all this information out, and then they were going to go get some moon dust that was taken from one of the moon landings and compare and see like, okay, are these from similar areas or of similar constitution? Are they different? So that's interesting too. It's like what we learn from the meteorites that land here can tell us about us and our beginnings at also outer space, like the moon.
Yeah.
Where did the moon come from? So that's interesting.
Yeah.
Okay. And then, so these, bits of rock, they sometimes are just pre-existing space debris. Sometimes they can get knocked off of really big asteroids that are just floating out. There's rocks that are like in orbit around something already with a gravitational pull to it. And so sometimes we'll get information about what is going on with those. And there's lots of different meteoroids with like different content of like carbon or silicone or different types of metal, like different things that are in different celestial bodies, question mark. Is that a good way to say it? And one thing that they're thinking of is like, okay, these things are coming to us and they're full of these metals, which are really valuable here on Earth.
Mm-hmm.
So can we go there and mine metal?
Mm-hmm.
And there's like theories that there are asteroids with enough metal in them that's like valued higher than our whole entire global economy.
Yes.
Isn't that crazy?
That is crazy. That is one of the plot points of For All Mankind, that space show.
Oh, yeah.
Alternate history space show, alternate timeline thing. That show is so good.
I think you told me to watch it before.
Yeah, you would love it.
Okay.
So it's like, it has it all. And it's not scary. Which I know would be like a not favorite for you.
Yeah.
So.
I don't like dark things. Although the book that I'm reading is dark, and I almost quit. It gave me nightmares.
Really?
And I was like, I don't know that it's kind of violent. And I'm like, I don't know if I could do this.
Mm-hmm.
But we were on a really long car ride, and Mason was like, let's just push through. And then it got good enough to where I could pay more attention to the plot than the violence, but I really almost quit.
Yeah.
It gives me nightmares.
Yeah, that's surprising. There are some things I've watched that have haunted me in that way, but it's not been like, it doesn't happen very often. But it would give me pause too if that happened to me.
Okay, so
yes.
Apparently there's, I don't know if it was a U.S. law or if it was a global law. There's laws that say you can't own an asteroid, but if you extract something from it, you can own that, which I'm like, okay.
That's interesting.
So in theory, we could get out to these asteroids and mine out all this metal and come back and be wealthy because we'll have metal that's worth more than the global economy.
That's crazy.
I know.
Yeah.
But the thing I was watching was like, wouldn't it be fun to have like a outer space gold rush? And I'm like, I don't know, because it feels like it would destroy this, like, I don't know if it's like the environment because it's outer space, but I don't want to mess things up more than we've already messed them up.
Yeah, you gotta watch For All Mankind.
Okay.
Yeah. So many of these questions you're asking right now are like, it's like the 4th season or something like that, so it'll take you a bit to get there.
Okay.
But this big asteroid with like just an abundance of minerals. But part of it is this like, oh, it's really helpful for the scarcity of certain things.
Yeah.
That honestly makes the price drive up of this stuff. That if we had an abundance of it, it wouldn't. So that's part of it. They're like, this is unnecessarily inflated because it's scarce here, or it's like way down in the crust where it's just hard to access. And in theory, getting it from this asteroid is easier or something. But there is a lot of these other ethical questions that come up about how do we do this in a way that's not just like benefits one country, you know, and there's so much like international cooperation for space stuff, you know, like the International Space Station.
Yeah.
And we've like frequently had crews made up of different nationalities and stuff. So then it becomes like this, okay, how do we do this in a way that benefits the globe? And how do we decide that?
Yeah.
A lot of interesting questions, and certainly people fighting and, you know, meeting in boardrooms and all that kind of stuff. But
well, and then I think there's also ethical questions of like, if you learn about how a lot of our precious metals are mined now, a lot of them are in the Democratic Republic of Congo, and they're like, it's very unethical the way people are treated there. Like, it's really concerning, things that I think we should care a lot about. You're like, so could we do it with technology in outer space and it'd be better for people, like human beings, but then worse for the environment?
Yeah.
Or what is it still called, the environment when it's space? I don't know.
Yeah.
Just things to think about.
Yeah. And we've done it before. So do we know what is like, do we know how to do it? You know what I mean? It's like, what else is it going to take, and are we going to get it right? And what are the unintended things that can happen? Obviously, they can calculate mass of an asteroid and what it's like to go like land on it or like attach ourselves to it or whatever. And that's all theory though, you know?
Yeah.
It's like, what happens when you actually do it? Like, what if you try to like attach to it and it kind of crumbles?
Yeah.
And it's like, just, you can't, you know, like what happens?
Yeah.
I don't know. Seems like there's like this crazy, it's one big hypothesis. It's
dude,
like,
what if we have an astronaut who listens to this podcast?
They'd be like,
these guys are dumb.
Yeah. Y'all are dumb. We know way more about that than you think. And also, it would cost so much money to even go try to mine from it that it wouldn't be worth it or whatever.
Okay, if you're an astronaut, we'd love to hear from you.
Yeah, if you're one of the like 200 people that have ever been to space that are still alive.
This brings me to our categories.
Okay.
So the category I was going to do for this time was, what is your favorite space story?
Oh, I love this question.
2 things came to my mind.
Okay.
One, when I was like thinking about how I was going to frame this story, I kept thinking of that scene from The Lion King when they were like, what do you think it is up there in space?
Mm-hmm.
And one of them's like, there are fireflies stuck in the sky. And the other one's like, I always thought they were burning balls of gas or whatever. And like, that was the right one. And, yeah. So I was like,
it's Pumbaa. It says that.
Yeah.
And it's just like, what? They're like,
yeah. They're like, okay. And so I thought about that when I was writing this. I was like, I'm going to feel like I'm the one who says that. But also there was an episode of Radio Lab. I'm pretty sure it was Radio Lab. Could have been This American Life, but I think it was Radio Lab, where they interviewed a guy who was an astronaut, and he talked about how he got into the situation where he was outside of the shuttle. And he was like having to basically try to figure out how to get back in. And if not, he was like going to melt. Like he talked about how they were circling the earth and like the sun was rising and setting so fast. And I remember just like I was in my chemistry lab in grad school. I was like cleaning my lab glassware. So basically just doing dishes, but in the lab. And it was like, it took me to another planet, you know, literally. It took me to outer space. And I was just like, people really do this. And it really messed with my brain.
Yeah. That's crazy.
And I think about that a lot. I kind of want to go back and re-listen.
Yeah. If you find that one, you should send it to me. Whatever it was, Radio Lab or American Life. But I love the movie and the book of 2001: A Space Odyssey. I've
never read or watched that.
They're both so good, and what's so rare about this is that the guy that Arthur C. Clarke, who wrote the book, also wrote the screenplay, and he wrote them at the same time. So there's not a book and then they went into a movie. There's not a movie that they didn't write a book about. They are one.
That's crazy.
And it's just, that seems like no one does that.
Yeah.
For one, the movie's amazing how it stands up to like it was written, filmed, and premiered before we ever landed on the moon.
That's crazy.
So their like ability to render some of these like space scenes, which obviously we had pictures of space and stuff, and we've been in space but not landed anywhere, and is amazing. And they have a whole scene on the moon, and he's one of the biggest reasons why there's the theory that we faked the moon landing, because it's like before we ever landed on it, 2001: A Space Odyssey had an amazingly convincing moon scene. And so that
it's like, so it kind of looks just like the fake one.
Yeah, it's like there's ever some differences for sure, but it did fuel that a bit. It's great, and I already said For All Mankind, so I don't need to say that one again. But definitely worth reading the book or watching the movie or both. I'm like amazed by that movie.
Okay. Okay.
And it's famous. It's one of those where like when you start watching it, you're like, oh, this is referenced everywhere. This is like a bit of like just American film canon, basically.
Okay. I'll add it to my movie list.
Although Kubrick is a British guy, so maybe you could just say, I don't know. It's like, I think it was filmed here, but we can't claim it as a fully American thing or whatever. But
that's a good one.
Yeah.
Okay, well, comment on our YouTube video or message us on Instagram and tell us what your favorite space scene is. And I'll message that podcast episode to you and probably to our patrons too.
Yes. Nice.
Yeah.
Sweet. Well, if you have questions, comments, thoughts, feedback, corrections, especially if you're an astronaut.
Oh, gosh, I would love to hear from an astronaut.
Reach out to us on our website at chemforyourlife.com. That's chem, F-O-R, yourlife.com to share your thoughts, ideas, questions, feedback with us. If you'd like to help us keep our show going and contribute to cover the costs of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. That's patreon.com/chemforyourlife. You get access to an extra bonus episode every month where Melissa and I just get to chat and talk about our lives. You get access to some behind the scenes stuff. You get an ad-free feed of the show, blah, blah, blah. Ways of us saying thank you for keeping the show going. We could not do this show without our community. You keep it free for everybody else. It's really important to us that it stays, that there's a free version out there for everybody. And so our community is very helpful. And if you've ever thought about doing it and checking it out, please go do that. Patreon.com/chemforyourlife. Start as low as $3 a month. Helps a lot. And we'd love to see you over there. But if you're not able to do that, you can still help us by subscribing on our favorite podcast app, rating and writing a review on Apple Podcasts and Spotify, subscribing on YouTube, leaving a comment, saying hey over there. Those things all help us to share chemistry with more people, help more people to find us and have the chemistry of their everyday life be explained to them.
I closed my browser on accident. So sorry about the delay.
It's okay. I can vamp a little bit. I can sing a little song.
I'm going to try to say it without looking at my notes. Wouldn't that be crazy?
That would be.
So we love our patrons and we're so thankful to you. We absolutely could not do this without you. So we like to give a little shout out to every single one of our patrons, every member of our community by name. So we'd like to thank Chris and Claire S., Hunter R., Katrina B., Scott B., Stephen B., Tim P., Vince W., Ash, Brian K., Chelsea M., Doreen V. Oh, Doreen, I've been telling so many people about hydrogen bridges. Elizabeth P., Emily H., Heather R., John T., Jesse R., Latila, Rachel R., Autoclave, Avishai B., Chelsea B., Sierra L., Cullen R., Erica B., Jacob T., Jeanette N., Julie S., Christina G., Suzanne P., Venus R., Justine, and Lynn S. Thank you so much for all that you do to make Chemistry for Your Life happen. And usually I've been saying the thing about for more.
Yes.
If you want to learn more about this episode, look at me. I'm going solo. Look, Mom, no hands. If you'd like to learn more about today's episode, you can check out more details in our show notes, in the info below our YouTube video, or on our website.
Mm-hmm.
Did I say it all? Did I do it right?
I think so.
Even though my browser was closed. Yay!
And also, yay, chemistry.
Yay, chemistry. Yay, space.